All right, so let's talk about what is a disk. Disk is a circular object that has a thickness. So to find the area of the circle, that's pi r squared. So to find the volume of one disk, that would be the area, pi r squared, times the thickness, dx. All right, so what we're going to do is we're going to be rotating an area to create disks. Last time we took cross sections and we took a slice. So this time we're going to be rotating a rectangle around an axis and creating a disk. So when we find the volume of one disk, we add them all up, and that gives us our integral. So there's our pi radius squared. This one we'll be putting in the radius. And then dx, we'll talk about how we get the dx integration as we move along. Okay, so here is, we're going to take the area that's bounded by these three functions, these three graphs. So y equal root x equal 4, and y equals 0 right here. All right, so the area bounded is this here. This is the area that's bounded. So we have to find the area first. And what we're going to do is we're going to spin this area. We're going to revolve it about the x-axis. So everything is about the rectangles. So if we're going to build a rectangle, and when we're doing volume by disk, we make the rectangles perpendicular to the axis of rotation. So rectangles are perpendicular, and I think you've probably seen that sign before for perpendicular to the axis of rotation. Can't say just the x-axis because it's going to change. We're going to be rotating around, but it has to be perpendicular. So now what I'm going to do is I'm going to spin it around the x-axis. This is my little notation to say spinning it around, and as it spins around, it makes a disk. So it makes a circular object of thickness dx. All right, and then the x-axis is going right through the middle of it. It's really important that you know where the center of the disk is, because as you can imagine, to find the radius of the disk, I've got to know where the center is to be able to count or to find out that distance there. All right, so there's my disk. So I'm going to be finding the volume by disks. So it's going to be pi radius squared, and you can see that the thickness of my rectangle that I'm spinning is dx thick, right? Dx thick here. All right, so now it's my job to find out what the radius is. So the radius is this distance from here to here, and that's just the function. So that's root x. So where am I building these rectangles from and to on the x-axis? So I'm going to be starting at x equals 0, and I'm going to be stopping at x equals 4. So from 0 to 4. So this, let's just finish this one off because it's a nice, pretty simple one. So squaring the root x. So I get pi x squared over 2. So pi over 2 times 16, or 8 pi. So it's a volume, so it'll always be a positive quantity if you're asked to finish off and solve the integral. Many times I'm going to just ask you to set up the integral when finding the volume. All right, so again, finding the volume. So let's look at what the area bounded is. So the area bounded is by these three functions. So these three functions. So let's get these three functions down correct. So y equal x cubed. Then I have y equals 0. So that's this here, right? Make sure we get that correct. Y equals 0. And then I've got x equal 8. X equal 8. That's here, correct? X equal 8. All right. So I'm going to be taking this area here and spinning it about the x-axis. So I'm really going to encourage you to kind of make a little arrow, remind yourself where you're revolving. And I'm going to say, okay, there's my rectangle that's drawn perpendicular to the axis of rotation, and then I see the disk that it makes. So let me just put it over here so you see that this rectangle spins around, right? There's the center line. It spins around and makes the disk. All right, so let's find the volume. It's going to be pi radius squared dx, because the thickness of the rectangle that I drew was dx thick, right? Dx thickness here. So now what is the radius? So the radius is from here to here. So that again is the function, x cubed. And where am I building rectangles from and to? I can see I'm starting at x equals 0 and I'm ending at x equal 8. So again, let's just finish this one off. So 0 to 8, multiplying these exponents, right? You get x to the 6th. So I get pi over 7, x to the 7th between 0 and 8. Pi over 7, so you get 8 to the 7th power. Again, a positive number. And that is the volume. All right, trig functions, your favorite. Let's do this last one. All right, y equals secant of x. So secant, you know, is the cups that come off of cosine. So it looks like I'm between negative pi over 4 and pi over 4. So let's get the cups here. We know these asymptotes are at negative pi over 2 and pi over 2, just to give us context, right? So x equal negative pi over 4 and x equal pi over 4 would be these lines here, right? And then I have y equals 0. Y equals 0 is this. Okay, so let's see if I can identify what the area bounded is. So the area bounded is going to be this here, right in here. Okay, again, I don't want you to color it in because I want you to be able to draw the rectangle. So this rectangle, I'm drawing it perpendicular to the axis of rotation. So it's the x-axis I'm revolving it about. If I spin it around to see the disk, right, it has a dx thickness, I'm ready to set up the integral. So volume is pi radius squared dx. So I'm going to be going from the x-axis up to the function. That's secant of x. And then I'm going to be taking the integral from negative pi over 4 to pi over 4, because that's where I'm going to start building rectangles at this and end building rectangles. So we know the antiderivative of secant squared. That's tangent. Negative pi over 4, pi over 4. Wonder, you think this will be a positive number? Let's check it out. So I have tangent of pi over 4, subtract off tangent of negative pi over 4. You should be able to do this without your calculator. So this gives me 1, and I'm subtracting off a negative 1. So this gives me 2, so I get 2 pi.